let's see how to work with complex numbers and the TI-Nspire CX calculator. And to get us started, consider the complex number 1 plus 2i. Now, as we're about to see, given a complex number like this one, the TI-Nspire will enable us to find its imaginary part, its real part, its argument, as well as its modulus, and it will also allow us to convert this complex number into polar form, also known as Euler form, and consequently it will enable us to write this complex number in Modulus-Argument form. But before showing you how to do all that, as silly as it may sound, we need to learn how to type a complex number on our calculator. Indeed, if I go ahead and type 1 plus 2i with my calculator, and if I click on the I that I have on my keyboard, like so, then if I click on enter, we can see that we're faced with an error message. And we don't really have a choice other than to click on OK. And the reason why we were faced with an error message is because of the way we typed I. Indeed, the imaginary number I needs to be typed with the special numbers button on our calculator. That's the button directly to the left of the letter H with a pi written on it. So let me go ahead and retype that complex number. I would have to do 1 plus 2. I then click on that special numbers button, and then I click on I. There we go. Now if I click on enter, everything is just fine. Okay, now that we know how to type a complex number, let's see some of the functionality we have thanks to this calculator. So to see what we can do, all we have to do is click on menu, followed by the second option number, followed by the last option we have here, complex number tools. And let's go ahead and work our way through these. The first function we have here is the complex conjugate function. And so if I click on that, to find the complex conjugate of, say, the complex number we started off with, all I have to do is type my 1 plus 2i, which again I've got to click on that button again. There we go, 1 plus 2i. Inside the pair of parentheses, I exit the parentheses and I click on enter. Done. We can now see that we have 1 minus 2i, which is indeed this complex number's complex conjugate. I carry on if I click on menu again, followed by number again, followed by complex number tools again. The second function we have here is the real part, so if I click on that, and if again I type 1 plus 2i, so that's 2, special numbers button I again, and if I exit those parentheses, I should be getting 1, since 1 is the real part of the complex number. And so if I click on enter, it confirms what I just said. I carry on, let's see how to find the imaginary part. So the path is the same, I click on menu, followed by number, followed by complex number tools, and I click on imaginary part. And once again, I simply have to type the complex number 1 plus 2i. I exit the parentheses, and since this complex number's imaginary part is 2, we should be getting 2. And so if I click on enter, we indeed get 2. Okay, now before I look at the other functions we have with this calculator, I have no doubt that you'll agree that having to go back to the special numbers button to click on I each time is a little bit tedious. So rather than retyping this complex number each time, here's something I like to do. I'll simply type it once, so that's 1 plus 2, special numbers button I, and instead of clicking on enter, I'll go ahead and store this complex number in our calculator's memory. And to do that, I click on the control button, followed by the var button. And you should see directly above the var button, it's written STO for store. So if I click on var, I can see an arrow on the screen, and all I have to do now is give my complex number a name. And so let's say I call this complex number u. We have u equals to 1 plus 2i, so I'll type u on my calculator, and now I click on enter. There we go. From now on, anytime I call upon u, it will be equal to that complex number. Okay, now that that's done, let's see some of the other functions. So again, I click on menu, followed by number, followed by complex number tools, and let's say we need to find this complex number's argument, which our calculator is calling the polar angle. So for that, I go ahead and select the fourth function here, polar angle, and I click on that. And this time, instead of typing my 1 plus 2y again, all I have to do is type u, I exit the parentheses, and I click on enter. And now we can see that the argument is equal to 1.11, where I've rounded to 3 significant figures. And I could specify in parentheses here, that angle is in radians. And I should say, if ever I needed to find the argument in degrees, then all I'd have to do is click on the radian button at the top of the screen here. And if I click on that once, it changes to degrees. And so I'll call upon that same function again, but this time instead of using the menu button, I'll just go ahead and type angle. Angle. There we go. I open up a pair of parentheses, I type U, I exit the parentheses, and I click on enter. And there we go. This complex numbers argument in degrees is 63.4. And I'll just specify that's in degrees. Okay, now for the most part when working with complex numbers, it's quite likely that we work with radians, so I'll change that back. There we go. Okay, now let's see how to find this complex number's modulus. And so for that, again, I'll click on Menu, followed by Number, followed by Complex Number Tools, and the modulus, which is also called the magnitude, is the fifth option right here. And so if I click on that, all I have to do now is type either 1 plus 2i, or again, I could simply type U. And so I exit that modulus or magnitude symbol, and I click on Enter. And we're done. The magnitude or modulus of U is equal to 2.24, where again, I've rounded to 3 significant figures. Okay, now let's see how we can use the calculator to convert this complex number, which here is written in Cartesian or rectangular form, and let's convert it to its polar or exponential form. And to do that, let me show you the function we'll use. So I click on Menu, followed by Number again, followed by Complex Number Tools again, and here the function we'll be using is the convert to polar. But before I actually click on that, when using this function, I need to start by typing the complex number that I wish to convert. So if I escape that, and escape that, I'll start by typing my complex number, and this time I'll type it out again. So I'll open up a pair of parentheses, and I'll type 1 plus 2i, which again, I go to the special numbers button, and I click on I, there we go. And I don't click on enter, instead now I click on Menu, followed by Number, followed by Complex Number Tools, and the sixth option, Convert to Polar. And all I have to do now is click on Enter. And we're done. Here we can see that 1 plus 2i written in polar or exponential form is equal to 2.24, which is this 2.23607 that I see here, but I've rounded it to 3 significant figures, times e to the 1.11i. And in fact, I'll go ahead and box that result. There we go. Notice here that we could have done this directly since we knew that the modulus or magnitude was 2.24. That's what we have here. And we had also seen that the argument was 1.11, which is what we have in the exponential place right here. But of course, it's also convenient to see how we can use that function. And hopefully it's clear that we could use this polar form to write this complex number in Modulus-Argument form. Indeed, we could also state that 1 plus 2i is equal to 2.24 times, in parentheses, cosine of 1.11 plus I times sine of 1.11. Good. Now again, here we're working in radians, but let's say we wanted to work in degrees. Then again, I would click on the rad at the upper right-hand corner here. So I click on that. I've now changed the calculator to degrees. And so let's say I now convert our complex number to polar form again. And so this time I'll simply type U instead of typing the complex number. And then again, Menu, Number, Complex Number Tools, and Convert to Polar. And I click on Enter. Notice here that when our calculator is set to degrees, instead of writing things in exponential form, it gives us the modulus or magnitude that we have here, as well as the argument in degrees. And so if we wanted to, we could also state that this is equal to 2.24 times, in parentheses, cosine of 63.4 plus I sine of 63.4. Alright, so those are the basic functions for complex numbers we have built in our calculator. But of course we could also do operations with complex numbers. And so to tidy things up a bit, let me just clear the scratch pad, and I do that by clicking on the dock button, and I scroll up once. There we go, and I'll clear the scratch pad. And so for the sake of seeing some operations with complex numbers, I'll go ahead and define 2 new complex numbers. I'll say v, which is equal to 2 minus 3i, and w, which is equal to negative 4 plus I. Okay, now let's say we had to find v cubed. Well, one way I could do that is by typing out the complex number and raising it to the power of 3. So I could do 2 minus 3i, which again, I've got to go back that button. There we go, 2 minus 3i. I exit the parentheses and I raise all of that to the power of 3, and I click on enter, and we can see right away that that's equal to negative 46 minus 9i. But of course I could also store that complex number, and in fact I'll do that now. I'll say 2 minus 3i. So again, click there and there. And again, to store it, I click on Control followed by the var button, and I'll call that v. And I click on enter. And now I can raise v to any power I please. So I could do v raised to the power of 3, and I click on enter, and of course I get the same result. And while we're at it, we may as well store the complex number w. And so for that, I'll start by typing negative 4 plus I. There we go, negative 4 plus I. Control var again, so control var. And we're calling that w. And I click on enter. And now we could carry out any operations we need. So for instance, we could do v plus w. So if I quickly do that with the calculator, that's v plus w. And I click on enter, which of course is negative 2 minus 2i. Or we could do v times w. v times w, click on enter. And so for v times w, we get negative 5 plus 14i. And we could also do v divided by w. So for that, v divided by w, and I click on enter. And so let's see, that's equal to negative 0.647 plus 0.588i. And in fact, we could do any calculation we needed to do with these two complex numbers. So for instance, we could go ahead and calculate 2v squared minus 3vw. And so I'll quickly do that now. So that's 2 times v squared minus 3 times v times w. And I click on enter. And we can see that's equal to 5 minus 66i. And there we have it. We can do all the necessary operations we need with complex numbers directly on our calculator, which will definitely allow us to save time in the exam room. Now to finish, let me point out one last thing which I didn't do earlier on. Indeed, we had seen how to get from Cartesian form to Euler form, which in turn allowed us to find the Modulus-Argument form. But let me show you very quickly how to quickly get from the exponential form, or polar form, to the Cartesian form. And so I'll quickly clear the scratch pad again. I'll click on Dock, move upwards once, and I clear the scratch pad. And let me go ahead and quickly define a complex number in polar form. And so let's say I've got a complex number z, which is equal to 3 times e to the 2i, where this argument 2 is in radians, so I'll make sure that my calculator is in radians by clicking on the DEG here. So I click on that and it changes to radians. Okay, so let me quickly define that complex number. I'll say that's 3 times exponential. So I click on the exponential function right here. There we go. And that's 2 times I. There we go. Now to convert this into Cartesian form, all I actually have to do here is click on enter. This calculator automatically converts any complex number written in Euler form into Cartesian or rectangular form. So without even thinking, we could go ahead and state that this is equal to negative 1.25 plus 2.73i, where again I've rounded these to 3 significant figures. Similarly, let's say we had a complex number written in Modulus-Argument form. And let's say that was in degrees, so I'll click back into degrees, there we go. And let's say we had a second complex number, I'll call z2, which was equal to 5 times cosine of 30, that's 30 degrees, plus I sine of 30. Well again, if I type that on my calculator, I'll do 5 times in parentheses cosine of 30, plus I, so plus I, there we go, plus I, times sine of 30. And if I exit all that and click on enter, the calculator will immediately write that in rectangular or Cartesian form. And so if I click on enter, there we go. We can go ahead and state that this is equal to 4.33 plus 2.5i. And there we go. Now I know this video was a little bit long, but hopefully you did find it quite useful in seeing how we can work with complex numbers on our TI-Nspire CX. All that being said and done, that's it for this tutorial.